showing you things in nTop platform, but what I want to talk about is kind of twofold today. Everything you're looking at on the screen, these are three entirely different parts that really have nothing to do with each other, but they're just interesting examples that I picked. And they all have holes in them, so that's one of the similarities. But the second similarity is that all of these came from the same workflow or process that I created in nTop platform, or what we like to call compound blocks sometimes. So let's jump into one of these, and I'll explain in more detail what's going on and where the power of this is. I'm actually going to delete that and start from the very beginning. Now, in nTop, if you've seen this before or played with it, it's got so many capabilities and so many powerful things it does. One of the things people like to do is punch holes in bodies or faces for one reason or another. There's several ways to do that, which in and of itself is really a powerful thing to do in nTop platform. But people have different needs and different reasons for doing things. We created a block, what we call a block, which is really the fundamental tool for getting anything done. It's this basic algorithm in nTop platform. We created a block right here I'm showing you that takes a given body and it just blasts it with holes, right? Because that might be what you want done relatively quickly. You see the parameters are exposed that you might need, right? And so again, we blast this with holes. I put a diameter in, and the radius is, or the spacing between them is basically fixed. And I've got minimal number of inputs in here, the hole size and the axis of rotation of how these holes are fitting next to each other. So if I put in something like 35 degrees, you can tell that these are going to be skewed ever so slightly. There's my horizontal axis, and they're going up about 35 degrees. Okay, so everything looks good. This has minimal controls to it, and it may not be exactly what you want. And depending on the application you have, it may not suit it. Now, speaking of applications, one of the things that we know our customers like to do is when they're doing a 3D printing process that involves powder, and you're shelling out a body and maybe putting a lattice on the inside, you can't just say you can't just do that without making some kind of a series of holes or a hole from which to extract out all the powder, right? So we've got a block here we created that takes that into an account, and it gives you a little bit more control than you otherwise had on that last block I showed, and this is called Perforate from a CAD face. So the difference is I'm selecting a body, and I'm selecting a face, and it's again putting holes all over, but there's a couple differences that I think you can immediately see. One of which is you've got a bit tighter control over the quantity of holes. Now in this case, I've got UV curves on this on the model, right? And that's dictating by those UV curves where the holes are going to go and how many there are. You notice that I've got some holes in the very center here, and I didn't even tell the system to include them on those faces, but it went ahead and did that. Now, just to kind of go back, there's three distinct faces on this model, and it went ahead and put some holes in the very center. And so it's taking the natural curvature of that main face I selected, which is right there. It's going ahead and putting holes everywhere. Now, you notice it didn't put a hole all the way through in the very center, and there's a simple explanation for that. The curvature of that face warrants that I need a greater depth than 2 millimeters. Now, 2 millimeters might be the actual thickness of the part, but in reality, well, it's going to need something a bit greater to actually poke its way all the way through. Now, for the particular application you may have and what you want to do, you may decide this block doesn't cut it for me, it doesn't give me the complete control that I want. And so what I did, I decided, well, I want to put holes in a model and I want to have more control than those two blocks are giving me. So I went ahead and created my own custom block that does exactly this. The inputs are pretty straightforward. As before, select a body in which I want the holes to go, and then a face and some variables. Now, I'm going to speak to each of these in this model as well as the subsequent ones in a moment. But you'll see what's going on is something that looks a bit different. Now, the similarity to before is I've got normal holes all over this model, but I've got a much different level of control than before. I don't have UV curves, but I've got an actual point count. So I know exactly how many holes are in this model. All right, so that's completely different than before. Of course, you could do the math somewhere and figure that out, but why do that if you need a certain number of holes and you're putting them in there? with a variable. I also have a what I'm calling a cluster of holes around this bump, and you can see the spacing looks a bit tighter. I'm going to talk more about that in the next two models. But know that this is not a cookie cutter example. This is a NURB surface created elsewhere. It's got a good amount of curvature to it. And you saw the round and the bump in the center, which is really spherical. But there is some complex curvature going on, but we're able to throw those holes in there with some level of precision. Okay, so that's the first model, the first example. Why might you use something like this? Why might you put holes in a body? Well, here's one example. If you're creating some tooling, maybe for vacuum forming, this is where an operation like this can come in very handy. And it really is this simple as far as I bring in a model and I designate the faces on which I want the holes to go, and I'm left with perforated holes all over. One of the important things about the workflows that we've got in nTop platform is just that they're workflows. You can use them on any CAD file or variations. So that particular file that I had, let me just go back to nTop. That particular file, its name was mold tooling, and it's a parasolid file. All right, so let's go to the CAD tool that I happen to know, Space Claim. And of course, any CAD tool that you work with is going to suffice for bringing files into nTop platform and doing some wildly complex things with them. When I model, I prefer to kind of work in a surfacing environment. So that's exactly what I'm going to do here, is say, let's play around with surfaces and let's just get rid of that solid body. All right, so I've got surfaces. What do I want to do here? Why am I even in a CAD tool? Well, I want to show you that you can start making some changes to the file and eventually bring this back into nTop after having made those changes. So I'm doing a couple changes that are a little bit simplistic, just a general shape of this. Maybe what I'll do is say, instead of this being a cylinder, let's turn that into a cone, increase it a little bit, and let's do a fun one. This is the axis of everything kind of lines up here. What if I change that axis? I mean, I could go something crazy, but let's make a little nominal change right there and maybe drop down the height of this thing. There we go. That looks a lot better, definitely different from before. I'll reattach all those rounds. I think that looks good. We'll go ahead and put a thickness back on that of 2 millimeters, and I've got a brand new part. All right, let's save this out. I'll save it as parasolid again. And instead of mold tooling, we'll call it mold tooling -2. There we go, done. We'll go back into nTop. And so again, this is a repeatable workflow. The only issue was I got rid of the entire solid body, right, and started with the surface. So I really need to define the surfaces. Again, it's a quick operation to do. And you probably didn't see this before, but I didn't have holes on that upper surface on the last version. So I'll go ahead and add that in there. And that's it. So this thing will now repeat itself going through. Before I do that, though, let's take this cluster center, which I haven't really talked about yet, and I'll move that to the very top because I want something to happen over there that didn't happen before. Drag the face list in, and this is going to start generating. Now, it's got 1,500 holes, so this is not going to be a half a second operation. It won't take several minutes either, but it's going to be relatively quick. But just to kind of repeat myself, it's running through that algorithm again to generate the random holes. And these are some of these faces are very simplistic, they're not difficult to understand. It's not difficult to put the holes on, but others are a little bit more complicated. So there we go, totally done. So a couple things going on. And I didn't actually put that cluster where I wanted to. So let me go back and do that. There we go. Now it's going to rerun again. But you saw the preview for a second there. So I was able to put the holes in everywhere that I wanted. But I want to draw your attention to two interesting things here. This relative spacing, it's a parameter I set up. So if I put a value of 1 in there, that means the spacing between all the holes is pretty much uniform. If I drop it to below 1, I'm saying I want a cluster somewhere. And that somewhere is what I've defined as just a single point. So it locates that point and says, I'm going to put a cluster of points, a cluster of holes around that point. Alternatively, if I increase this above one, I'm going to have a void. All right. So I'm not a mold designer. I'm not pretending to be, but I'm here just to show you to kind of expose you to the capabilities of what you could do and the power of this. So I've created the cluster of holes. You can clearly see that the spacing, let's change my color to green, is much greater in that center locus as compared to anywhere else out in the perimeter. And by the way, if you ever want to see a better rendering of this, this is just a quick rendering that we give you on the screen so you get a preview of what's going on. And in order to get it to you quickly, we sacrifice a little bit of the quality. So, but at any time, you can get a perfect rendering done and see exactly what's going on. All right, I think that looks pretty good. That's going to do it for this model. Let me go to the third and final one, sort of bring it all home. I'll start with the very end and then kind of work my way back up to it. But this is what I want to get to, this phone model with some holes on it. Now, I don't want to start in just that file. I actually want to go into the file that defines my compound block. So I'm opening up the guts of this thing and I'm going to show you what it does. My goal isn't to teach you everything about this file, but it's really, again, to just expose you to some of the capabilities that are in here. There's no smoke and mirrors. I'm going to make this file available so anybody and everybody that wants to use it and do some things with it, feel free to. So what I have is the original phone case. Now, if this looks familiar, it should. If you've seen some other nTop lives that we've done, my colleague Andrew several weeks ago created some beautiful surface textures on this file. I watched it and was really impressed. I actually learned several great things from it. So I'm taking the same model and I want to show you on the negative, if you will. Another colleague of mine wisely pointed out, why, John, if you ever show that again, you ought to show something on the tooling, because that's probably what people really care about. So that's exactly what I'm going to do right here. All right, so I'm just creating some variables, doing a little bit of housekeeping to make things easily accessible for myself. Same thing as before. You know, this file should look very similar to the compound block I showed you right here, right? There's some variables exposed and that's it. You just see a couple more pieces of data on a file like this. But let's take the CAD faces, let's take the body and dump it all in there. Before I do that, before it actually rebuilds, let's put some variables in there that I know about or that I care about. I'll say my part thickness is only a fraction of a millimeter. And that's because I don't want the holes to actually poke all the way through this. This is the mold. So I want something to happen to the texture, to the body itself. Let's increase the relative spacing to something a bit higher this time, because I want a void to go on this phone case, maybe where a certain logo might exist. Okay. And I think that's it for those variables. We'll dump in the body. And it's rerunning now. It's just running through the whole thing. Let me just kind of take a minute and pause and show you how this thing works. It's really going sequentially from top to bottom. And again, my goal is not to teach you everything, but just to expose you what was done so you can open it up and try to play with this and claim it your own and do whatever you want with it. And hopefully use it for something, you know, realistic on your parts. The surfaces on which I want the holes, well, I've just turned those into a mesh. Why did I do that? Well, that mesh body is going to turn into a series of random holes. Each and every point is going to represent one of the holes on the body. So where I mentioned the logo would go, you don't see as many points there. I could certainly drop this to 0 if I wanted to, meaning 0 points, but I don't think I want to do that quite yet. Now let's go into the main block here. Don't be intimidated by everything that you're seeing. It's really not all that complicated. But again, every point I created, what nTop did was create a little post. Now, I'm actually going to increase my thickness to quite a bit more for just a moment so you can really see the effect. And so it's going to be a little bit ridiculous for a moment, but just to sort of prove out a point. How did I do this? How did I create all those posts? Well, I created a series of points all over. And let me zoom in on these points and you'll see what's going on. Let me explain this in more detail. This point right here is the exact inside surface of the mold or the outside surface of your phone, right? Well, all I did was say, let's create a copy of those points going in one direction and a copy going in the other. And these are at different distances. Well, I intentionally set that up. It's just a function over here of the maximum thickness that I entered. So you see I've got some values of -0.9 and 1.8. And so that's dictating how far apart those points are going to go. So this begs the question, John, what direction do the points go in? How do you do that? Well, this entire workflow kind of revolves around this one very useful block called evaluate field gradient. It's just a fancy word to say, find the normal vector. We find the normal vector, we start moving points in that direction, we connect them together, and we create some posts. And those posts are used to start cutting away material from the model. All right. So if you go back to thinking about, how this is useful and what's actually going on with this mold, let me hide everything except for the final part. There it is. It is making some small indentations in this part. All right, so let's go into that high-res view so we can really see what's going on and know what my model's going to look like. If you're holding your phone case, you're going to feel some small bumps. Maybe they feel like braille bumps on your phone case. You may say, John, you've got some really sharp edges there. Gunk could get caught, or it's just maybe not a good practice. Yeah, I agree. That can be a complex operation in traditional systems to actually remedy that and put a round on it. Here in nTop, I change a variable, and now I've got a radius that's actually bigger than the diameter, or the depth, I should say, 0.15 millimeters, and I've got a radius all around there. So again, you're holding your phone case, and you're going to have some bumps on your hand. Maybe you say to me, well, John, I don't have a phone case that I'm doing a mold with, but I actually want to create a depression on the final part. So it would be an emboss on this model. How would I do that? Is it simple to do? The answer is yes, it absolutely is. Think about it though. I took the main model, which is right here, I'll isolate it, and I said subtract away those posts. What if instead I added the posts together to the main model? Well, instead of a subtract operation, that's really just what we call a union. And so I'll do just that. This repeatable workflow I've created, I just happen to call it perforating holes in the normal direction. You could call it anything you want, and you could actually have two outputs. One would be holes and one would be slight embosses. And so here you've got embosses, right? Let's isolate this and go back to another high-res rendering. It's embosses on the tool, but it's holes on your phone, so you get to choose whatever you want depending on your application. The point is that I didn't create a couple models that have holes on them. Yes, that's a part, but the bigger picture that I think you guys are getting, I'm really driving home, is that I wanted to do this and create a repeatable workflow, so no matter what the part is, I go expose the variables I want, and I get the end result pretty fast. So I put in a little bit of work up front to create this repeatable process, and I'm done. So that's all I wanted to show you guys today. I went a little bit longer than I thought. So let me go look at some of the questions coming in. A couple things. I mentioned that there's no smoke and mirrors in this, and there really isn't. If you want to get a copy of nTop, contact us. We can see about doing that. If you want to get these files, we're going to put them on our website along with this video. Go watch it, open up the files, do what you want with it. Contact us if you have any questions. Okay. Would it be possible, one question that came in, would it be possible to increase the hole density or the number of holes with a field? Not so much the diameter, but how tight they are between them. Absolutely it is. And that's exactly what I did with this relative spacing block right here. So again, I've done this right around, and this question came in maybe before I answered it, but my cluster is centered. Let me draw it in, I don't know, let's change it to green. My cluster center is somewhere right around here. So I've told the system, you know what, let me actually go into that block and show you what was done. Here it is. It's a ramp. This is probably my favorite thing in nTop, this whole ramp block, right? I created, you can see it on the screen, a really, really, really tiny sphere. Okay, it's sitting at the center. And I've told the system, whenever you are right on the edge of the sphere, the relative spacing should be 1, okay? Then I've said, let me change the color to like purple here. Whenever you get really far away from the sphere, and I used a function to do that, then I want the relative spacing to be 25. This was just the way I happened to set it up. You can put absolute values in there, and you don't even have to have the field be a sphere. The field could be anything and everything you want, all the way from a point, all the way up to a complex geometric shape, all the way up to imported data from, I don't know, say simulation data. That could be your field that's driving the spacing of all these. So the world's your oyster, as they say. You get to pick and choose how you want this done. The capabilities are endless, and the power of it is it's actually a lot of fun to play with. I hope you can tell. I'm having fun with this. I'm going to call it an nTop live session there. We're going to be done. More questions, if you have them, send them to us. We'd love to answer them. Again, my name is John Graham. I direct the application engineering team. Would love to answer some of your personalized questions and see how we can fit into your application. So thanks everybody for watching, and make it a great day.